Hello, I'm Avril Sauter and you're watching Conducting Cisco Unified Wireless Site Survey course offered by TrainSignal. In this lesson we're going to be talking about regulations and the different ratings for equipment. And this can be a little bit of a dull module because we're just going to go through a lot of data and a lot of facts, but it's absolutely critical that anybody deploying wireless networks really understands the regulatory issues, the compliance issues, as well as some of the health and safety concerns around wireless. So let's go through what we'll be covering in this lesson. I'm going to start with a discussion on regulatory requirements for operations in the spectrum band. And I'll start with a taxonomy, explain some of the terms, etc. that you need to be aware of. And after that, then what I want to do is actually use the US as an example to help really understand how that regulation is put into effect. Now, when we talk about regulation, it's just not spectrum, but it also impacts safety as well. So we're going to talk about safety codes, and again, I'm going to use the US as an illustration of the types of safety codes that you're going to find that are in place and will impact the deployment of wireless LANs. Then we're going to go through some equipment ratings for when you're deploying access points in hostile environments. And what do I mean by hostile environments? I'm talking about weather conditions, where they might get wet, snow, etc. And then we're going to finish up with a demonstration where I'm going to show you how you can go in and change the power level that you're transmitting at on a Cisco access point. And in this first section, when we talk about regulatory requirements, you'll realize why they're so important when you're doing your spectrum survey. So let's start with our discussions on the regulations that impact the spectrum itself. Now, let's first talk about what it means to be licensed versus license exempt. So license is when you have to pay for a license fee, and this would be things like your mobile operators. They're licensed to operate in that band, and therefore they have exclusive rights to use that band. Wi-Fi is deployed in the license exempt band, which means that you do not have to pay a license fee. But not paying a license fee doesn't mean that it's not regulated. And in fact, the license exempt band, or as we refer to them, the unlicensed band, are actually heavily regulated around the world. Now, the ITU does make recommendations for different countries to follow in order to get some consistency between the different countries, but spectrum is very much managed by that individual country. And here in the US, that would be the Federal Communications Commission, the FCC. And as I said, we're going to be talking about some of that regulation a little bit later in this lesson. So one of the first things that is regulated is what is the spectrum being used for. And here you can see that different countries around the world are using the 2.4 gigahertz band, but the amount of spectrum that they've made available is different. So if you look here in the Americas, we have allocated channels 1 to 11 in the 2.4 gigahertz band. Whereas over in Europe, ETSI has actually allocated 13 channels, so they actually have more spectrum made available to them in Europe than we have here in the States for our wireless LAN deployments. And here in Japan, you can see even more spectrum being made available by the regulators. So again, when you deploy your wireless LAN and you configure it to operate in a specific country, what's going to happen on that access point is going to say, okay, that means I'm going to operate on these channels. Names for the frequency bands also differ in different regions of the world. And here's an illustration in this table. So in Japan, for instance, years ago for Wi-Fi, they just deployed it in the 5.18 to 5.32. And then a few years ago, they released more spectrum available. So they call the older frequencies just the 5 gigahertz band, and then the newer frequencies, the 5.47 to 5.725, the new 5 gigahertz band. In North America, we use the terms Uni 1, Uni 2 bands, Uni 2 extended bands, and then the Uni 3 band. Over in Europe, they're called Sept A, B, and C. So different countries around the world will call the bands differently. Sometimes the bands look very similar, but the frequencies are slightly different. So it's really important when you're working in different countries around the world to make sure you're using the right name and to make sure that you really understand exactly what the frequency band, because it may be different. Now, when we look at spectrum regulation operating in that unlicensed band, one of the big things that's controlled is the power level, your transmit power level. And because we're dealing here with unlicensed band, and we want to enable lots of devices to operate in the same band, so the regulators really control the transmit power level, so that actually then reduces the size of your cell and then allows other devices to operate around you. Very different from the licensed band. For instance, if you had a cellular spectrum license, one of those big towers can go all the way up to 40 watts. Whereas down here in the unlicensed band, we're going to be down at the sub 100 milliwatts. Now, the thing to know is that the regulation is not consistent across different unlicensed bands. So the regulation in the 2.4 gigahertz band is quite different from the regulation in the 5 gigahertz band. So you should not make any assumptions that if you understand one band, those rules apply to the other band. The other thing that's incredibly important, especially if you're doing outside deployments, is that the regulation is different for a point-to-point connection versus a point-to-multipoint connection. So a point-to-point, maybe you're doing a bridge between two buildings where you're just connecting two buildings together. It's a point-to-point connections. The power regulation is different than if you're doing a point-to-multipoint connection where maybe you're deploying an access point in an office and many people are communicating to that access point. Now, one thing that's very important to understand is that if you are going between two buildings and you are using an omni antenna, and we're going to talk about antennas in a moment, but antennas that radiate equally all around in equal directions, that is considered a point-to-multipoint. So even though you might be using it to go from one point to another point, if you're an antenna that transmits all around and creates interference right around that access point, that's considered point-to-multipoint. And so the point-to-multipoint regulations apply. If you want to take advantage of the point-to-point regulations, you must use a directional antenna. Now, when we talk about regulators regulating the power levels, what they're regulating is the emitted power from the antenna, and that emitted power from the antenna is called the effective isotopic radiated power, the EIRP as we refer to it. And so we're going to talk about what does the EIRP mean, and we're going to go through an example of how you would calculate it. So the EIRP is the maximum power that's transmitted from your antennas, so that radiated power, into the physical RF medium, so out into the air. And that's what's regulated. And you calculate your EIRP quite simply by taking the power that you're transmitting from the access point, taking away any losses that you might have incurred in the cable and the connectors, and then adding in any gain from the antennas. So to help you understand how to calculate the EIRP, I formed this simple chart here, and imagine, if you would, your access point was transmitting with a power level of 20 dBm. And let's say you were using an external antenna, and let's say you had a cable run and you estimated the cable loss was about 2 dBm. And then you had a 6 dBi antenna. So that would then give you an EIRP of 24 dBm. So as long as that was below the legal requirements for operating in that band, you would be able to deploy that access point with that antenna. Now let's take another example. Here, my transmit power I've dropped down to 12 dBm, but notice that I've got a much higher gain antenna. So in this case, I'm using a 10 dBi antenna. I've still got 2 dBm loss in the cable, and so that would give me a total transmit power of 20 dBm over the air. So again, when you're calculating your ERP, you take your transmit power plus any cable loss and then add your antenna gain. So I want to use the regulations in the United States as an example of what these regulations look like. And again, you have to look at the regulations within your specific country when you're deploying your wireless LAN. Here I'm looking at the operations in the 2.4 gigahertz band, and here I'm looking at the point to multi-point. So this is from one access point to many clients. And you'll notice here that the maximum transmit power is 30 dBm and the maximum ERP is 36 dBm. So in this illustration here, you can see if I'm transmitting at 30 dBm, which is 1000 milliwatts, if I assume a zero cable loss, an antenna gain of 6 dBi, then you can see that I've reached my maximum allowable ERP. In other words, 36 dBm, and I could not put a higher gain antenna on that while transmitting at that power level. But you can see down here in these lower examples that I have got 12 dBi and 16 dBi. But notice that I have reduced down the power levels such that when you take the transmit power level plus any cable loss plus the antenna gain, you'll get back to the 36 dBm. And so, for instance, if I use the 16 dBi antenna in this example, my transmit power have to reduce it down to 100 milliwatts. This is referred to as the 1-to-1 rule. If I increase my antenna by 1 dB, I have to reduce the transmit power by 1 dB. So let's now take a look at the point-to-point deployments. And remember here, you're talking about a directional antenna, so you're focusing the energy in one direction. So for point-to-point, there's actually an exception to the maximum ERP rule of 36 dBm. You still have a maximum transmit power of 30 dBm, but the maximum ERP is changed. And in this case, you follow what's referred to as the 3-to-1 rule. So let's take a look at what that looks like. So in this illustration here, you can see I'm transmitting at 30 dBm, my maximum power, and I'm assuming a zero cable loss here and a 6 dBi antenna, just like we saw before. And of course, that gives me my 36 dBm maximum ERP. But look what I can do now. I've moved to a 9 dB antenna. So I've increased it by 3 dB, but I only have to reduce the power by 1. So it's that 3-to-1 rule. So I reduce down the power level by 1 dB. And here again, I keep going. I get up to a 12 dBi antenna. I only have to reduce the power by 1 dBm and giving me a total transmit power of 40 dBm over the air. So again, this is point-to-point communications. So here we're looking now at operations in the 5 gigahertz band, still within the US. And what you're seeing here, that in the 5 gigahertz band, it still follows the 1-to-1 rule and the 1-to-3 rule for point-to-multipoint and point-to-point that we saw in the 2.4 gigahertz band. But now look at the table. What you're seeing here is the 5 gigahertz